Thank you very much. And thank you, Professor Mehta, and especially Rajan. We had 3 days of extremely important and thought-provoking presentations and discussions, but the kind of hosting that Rajan provided is amazing. We were completely spoiled, and would like to really thank Rajan. This having been said, we were here for work, so we worked quite a bit, and I'm sure everybody that was participating felt the need to put in their hours, starting at 7:30 or something and finishing in the evening. It was a tough meeting. So I'm here to talk about the Energy in Buildings and Communities Technology Collaboration Program. I'm going to proceed. Actually, can I have a show of hands who knows what a technology collaboration program is? Yeah, yeah, you guys don't count. So I'll talk a little bit about that. Then I'm going to talk about our mission statement and provide an activities overview. I'm sure the students around will see a lot of their work relating to a lot of the work that is being done. And you see the rest. So the IEA Technology Collaboration Program, or TCP, are a collection of research activities that are internationally collaborative and that bring together experts. And the experts in the TCPs working to advance research and development and commercialization of energy technologies. These programs span, I think there are something like 36. So they go from atomic energy to buildings to hydro dams. So there is a broad collection. I hope this presentation is going to be distributed. The link there leads you to that. The scope and strategy of each TCP is in keeping basically with IEA. So we have IEA, and the TCPs are essentially it's not quite, we do not report to the IEA, but essentially we are at an arm's length of the IEA. We are completely independent. The decisions that we make depend on the representatives of the 26 countries, some of whom are here. Overall, these collaborations involve more than 6,000 experts and represent nearly 300 public and private organizations in 55 countries. The IEA-EBC, however, is concentrating only on buildings. So our mission statement is the one that you see here, is to support the acceleration of the transformation of the built environment towards more energy efficient and sustainable buildings and communities by the development and dissemination of knowledge, technologies, and processes and other solutions through international collaborative research and open innovation. I think the EBC is going to be enriched if India becomes part of it, and Rajan, who is already active in a number of annexes, can sit at the table and take decisions that impact the future research projects that we have ongoing. Most people that you see that are here from us is the executive committee. You see there are 26 countries, and essentially the role of the executive committee is to evaluate new projects, approve fully developed proposals, and then on a semi-annual semi-annually we'll evaluate those projects to see if the progress is being made. Each country's researchers report to the delegate of and gets their funding from the country itself. There is no funding from us, essentially, like directly from the EBC. The EBC is somebody, like it's a bunch of people that you see around that has the knowledge that could guide the researchers. We have a lot of people working in this. Like, I estimate that there are 500 teams from the 26 countries. One of the things that we want to do is essentially talk with the operating agents and get an exact number for how many researchers we have. And when you consider that 500 teams are more than 1,000 or 2,000 researchers and their students work in this context, and they work to address the retrofit of existing buildings, deliver net zero new buildings, address embodied carbon in new construction, address electrification of the built environment, digitalization, and ensure the energy efficiency and decarbonization measures for buildings are future-proof. Because sometimes we have to have a vision beyond the next 5 years. We have to consider the fact that, some things that we do today may have adverse effects tomorrow. So, it's important to have a holistic approach to the research. I'm not going to go there. The students can get my email from Rajan, and I will respond to that because it's very, I'm not going to go through it, but I'm going to say a few words regardless. Basically, a researcher from India, let's say, when India is going to be part of the EBC, comes up with an idea to develop a better wall system for residences, or a better indoor air quality or air cleaning system. Usually the researchers have a network. The researchers do not work in isolation, so they will talk with some of their friends in Canada or in the US or in Italy or in Brazil, and they meet and they decide, okay, we'll put in a project concept. So this is a 2-page concept that they bring to the executive committee and discuss it. The executive committee can suggest changes, can say, think a little bit more about it. It's too big a scope, or it's too narrow, or are you sure that this would work? Maybe they will send them back and they will come back. And once they get approval for the project concept, they go and develop a full project proposal. We call them annexes. And these annexes are basically project plans, management plans with details, with who is going to be doing what, who is going to be leading what activity, how long it will take for each activity. It's just like a project, like a construction project, except we are creating new knowledge. And then bring it back to the executive committee, and we say, again, you have not considered this. It's important for people around the executive committee to have an understanding of the research in built environment. We cannot really provide information without that kind of knowledge. So again, I'm pitching Rajan. Rajan will provide us with a lot of knowledge to help us with the different projects. So these are the ongoing annexes. I separated them in different ways, and maybe some of them are, I think they are up to date. Like decarbonizing the building sector, one of the annexes, for example, it's smart materials for energy efficiency, efficient heating, cooling, and indoor air quality control in residential buildings. Actually, this annex was created before the original developers of these materials. They're called MOFs, I don't remember the exact. They won the chemistry, Nobel Prize for Chemistry. So the work that is being done at this, in this TCP is innovative, is groundbreaking, and in a sense prepares the industry and individual countries that participate in these annexes. For example, to bring things up, Stephen is going to be talking about grid integrated control of buildings. This is something that is critical if we want to have electrification. Right now, the buildings are considered a load, and load does not participate with the grid. However, what happens is that you have solar, you have PV, and these are not constant sources of energy. So rather than building huge systems to produce energy, you engage with the buildings in order to modulate their desire to draw energy. So like the system as a whole can handle these intermittent issues. You talked about, Dr. Mehta, you talked about indoor air quality. The human-centric building design and operation of changing climate is not directly related to indoor air quality, which, as you see, we have specific things further down about creating healthy and productive indoor environments. However, in general, engineers, maybe not so much architects. Are there architects in the house, in the building? Okay, I have to be careful. The codes, for example, consider the buildings as something that is block. You know, like when you do an analysis of the efficiency of a building or the design, you consider a pie kind of presence of individuals. This cannot be further from the truth. So in terms of making the buildings more livable, it's important to have the considerations from the get-go, not later when you have built the building and then you have to put a bunch of controls to try to make it work. You have to give it some thought ahead of time. Which brings me, since I talked about the codes, to the Building Energy Codes Working Group. This is a grouping of people that, well, we enter a new phase, but it would be really helpful if we have somebody actually sitting on the Building Energy Working Group on codes from India. I leave it there. It would be really, I'm sorry? Oh, okay. But we would be very interesting because it's not an annex. Annex is a project that has legal implications. So like everybody has to sign that they have the funding to complete their 3 or 5 years. A working group is much looser. It's a kind of meeting of experts that have interest in the same kind of context. And this allows us to be much more flexible than an annex. For example, we do not really have to get complete approval from the EBC EXCO, but we have to provide our plan so that they know what we are up to. In terms of results, like as you can imagine, the vast majority of the researchers are university researchers and their students, and so peer-reviewed journal papers is a must. Full scientific reports are generated at the end of the annex and are posted on EBC, which is completely accessible. If you go to EBC website, I have it at the end of this presentation, you will find a wealth of information about different research past and even present that are being populated on a regular basis. So like design guidelines, fact sheets, and software tools. Our website is a little bit dated, and we have a new team dealing with communications on our end, and we hope that we are going to be able to have a broader impact across the industry and governments in a way that is easier to consume and apply in the different parts of the industry. The thing in red is something that we have addressed relatively recently, in the last couple of years. And essentially, researchers are preoccupied to a large extent by producing, developing new knowledge and publishing results. However, the time that takes for a published paper to go into a policy in the federal government or the local government is tremendous. Like there is these two organizations, like the researchers and the policy and program people, do not talk the same language. So we have developed a system. Well, no, it's a masterclass for writing for policy. It's on our website and it's publicly available, so you can go and check it out. And the idea is that when a new paper comes up, the researcher can write a briefing, for example, an effective briefing to the local government to say, you know, like indoor air quality can be used like this, like this, like this, in the language that the policy would understand, as opposed to technical. I'm a researcher as well. We tend to write for other researchers, and policy makers are generally economists, not engineers. So when they see something that they do not understand, they just put it aside and move on to something else. So in conclusion, I'm going to say that the emphasis of our TCP is on a holistic view of buildings. It's something that is very fundamental. A lot of times, it's my pet peeve. People concentrate on heat pumps, on windows, on motors. Those are important and necessary, but unless you see the building as a whole, as a system, they will not work. They will just be useless. Like you will not get the necessary performance out of them. And if we go one step further, I talked about the electricity system. If we want to make a country more energy efficient, we have to consider the whole system, the electricity system, from the distribution system, the buildings, and also if there are people that, I do not know if there is thermal networks in India, but whether electrical or thermal grids, it's the same problem. And with that, I would like to invite you to join us. It will be a real pleasure, and it will benefit us, and it will benefit everybody around. Thank you very much. Is there time for questions? Oh.
I open the floor now for question answer. Do we have any questions from the audience?
You there? No, yeah, you that turned out. What is your degree? That you're, yeah.
I am in the lab assistant.
Okay. And do you see anything of interest in what I talked about?
I don't know English.
Oh, I'm sorry. Your English sounds good, though. But I understand. Thank you. Don't be shy. Okay. As you wish, I am going to be sticking around for the rest of the day, so please feel free to come and ask me any question that you may want. Thank you.
Yeah, sure.
Just one quick, request is, can you talk about some? I know I have seen a lot of exciting outcomes of these annex projects.
Yeah.
Can you talk about 2 or 3 examples, or example projects or outcomes which you think that annex has led to? That will be very helpful, I think, for this audience to know.
So I'll give. Oh, yeah. Sorry. We talked about indoor air quality. Annex 86 developed a lot of information and is actually influencing standards, like international standards and local standards, to improve the indoor air quality, how we measure indoor air quality and how we achieve indoor air quality. Another one that comes to mind is the work previous to the one that Stephen is going to be presenting about data data-driven buildings. His work is essentially feeding into the government of Australia and influencing how they are going to be integrating the smartness of buildings. So, and another one could be it's been a while. There was a joint annex for net zero buildings. Like this was a combined annex with the solar heating and cooling and EBC. And essentially it laid down the groundwork on a lot of the activities that followed in that area. And again, I come back to the fact that we are looking at systems, not individual. So the 3 annexes, the net zero buildings, it's because they are considering that as a whole. The data-driven building, again, as well as the indoor air quality annex that I mentioned earlier. But I invite you, Yash, to go on the website and to click on the results, and you will see there is amazing information that's available.
Right. I mean, I have seen Halle's work. I think Halle is leading that 86, right? So I just wanted the students to know about these great outcomes. So thank you.
Thank you. Thank you for your question. Yes?
Maybe I'd like to add to that many of the building simulation tools we use today stem from some of the annexes in the 1980s and 1990s, like a lot of tools to investigate moisture performance of the building envelope was a result of IEA Annex 24. A lot of the airflow network models were stemming from annexes. For instance, COMIS was a tool which was a result of one of the annexes, and that also goes for building and other building energy simulation tools. So I think that is also a very, very visible result of some of the annexes.
Definitely, definitely. And you know, like this makes me think about the fact that annexes do not occur in isolation. Annexes generally have a life that extends long. Annex 5 started in 1977. This is the only one that is the same name, but other annexes see their progression like the same researchers work on individual problems, they solve them, then they identify new ones. So they become like a real network, and that continuously grows, essentially.
Thank you.